In this next example, we want to look at $10,000 that's put into a CD that is paying 2.4%, and it is compounded quarterly here. And we want to complete a table showing the accumulation for 2 years. And we're going to check our answer using the compound interest formula. So here's the table. Let me show you how you get that. First, we need our quarterly rate. So we want to take that 0.024 and divide it by 4. So the annual rate divided by 4 is 4 quarters. That'll give you 0.006. And the easiest way to generate this table is in Excel, Microsoft Excel. So let me show you how to do that. So here I have got my column period, which is your time, the amount of interest earned, and then the balance. So at time 0, we have $10,000. Now, after one period goes by, this $10,000 has earned interest. One period is going to be 1 quarter. So 1 quarter goes by. This has earned 1 quarter of interest. So how do you get that interest? Well, in Excel, you always start a formula with an equal sign. And then we're going to take the balance, 10,000 that's been in there, and we're going to multiply it by that 0.006 and enter. So $60 of interest in that first quarter. And then our new balance is going to be take the old balance, 10,000, add on that interest. So I'll start the formula with an equal sign. I'm going to click on that 10,000, click a plus sign, and click on the 60 and enter. So 1,060. And then you can just highlight these two formulas and click this, double click this little square in the lower right hand corner, and that copies those same formulas down. So this did the same thing. Cell D4, which is the new balance, column D, row 4, times that 0.006, that's your interest. And again, this is principal times rate, and then time is 1. So we really times 1 because 1 period's gone by, but we don't need the 1. So we can see that our ending balance here was $10,490.20. Well, let's go ahead and check that with the compound interest formula here. So our PV up here in front, that's our 10,000. And then times 1 plus R, so this would be 1 plus the 0.006. And then we have to get n as our exponent number quarters. So 4 quarters per year times 2 years, 8 quarters here. So 8th power. And if we compute that, 10,490 and rounded, it'll be 20 cents. So we get that same answer. So you guys can create your table either by hand, or you can do it in Excel, and you can attach an Excel file for the corresponding homework problem here. Now, just some quick notes here about compound interest with finance problems. So the sequence of balances in our compound interest table, they form a geometric sequence. So to get each successive entry, you're going to multiply by 1 plus R. So if we go back here to our balance table, you get from this entry to this one by multiplying by 1.006. And then from here to here times 1.006. So you multiply to get the entry below. That's kind of a shortcut. So it's a geometric sequence. Multiply to get the next term. I equals PRT, principal times rate times time. That's the simple interest formula. It does not work for compound interest problems except if you've got 1 period. So we use that to get the interest for 1 period. So if only 1 period goes by, there's no compounding. So simple and compound interest are the same. Also, when you work with an interest rate and a time period, your rate and time period must agree. So for example here, when we figured our interest, we had to do quarterly interest because our period was in quarters. So, and this interest rate had to be a quarterly rate. So if you're doing number of months, you've got to do a monthly rate. If you're doing number of years, you've got to do a yearly rate. So the time and the rate unit must agree. And then we'd seen in previous example that sometimes we get some counterintuitive results. We had that $5,000 that grew into over $100,000. But if you have very long time periods, sometimes it's counterintuitive. So as you go along, just kind of notice the results, and you should be asking yourself if it makes sense. So sometimes you lose your intuition with very long time periods, but hopefully that'll grow through the units. Also, price increases due to inflation are going to behave just like a bank account where interest is added, but M is equal to 1. So inflation is 1 time per year. But if you figure what's a gallon of milk going to cost in 5 years, it's just like you took that money for a gallon of milk, put it in an account, and compounded it once per year.